Hello, good morning. Happy Monday. How are you all doing? It is a Monday today. I got actually like a 15-minute start. I had to skip like half my morning routine. And I'm here like 1 minute later than my latest time that I said that it would normally be. Start at 6:45. Got that, but then 11 minutes later, real start. But I got actual caffeine tea, so in like 7 minutes, when that finishes brewing, I can well, then I guess wait till it's cool enough to drink, and then I will get enough energy to actually think straight. So until then, it's tired me. Anyways, enough about me. How are you all doing today? How was your weekend? So I've got an experiment that I'm trying out for this project. Since we finished the last one, and I'm in the middle of like after hours going through and like updating that, sharing that with my parents and getting feedback and all that fun stuff. I figured I'd try. We can revisit entity component systems, but with the end goal of creating a like a tutorial or at least a preparation for like maybe a meetup, conference, like a video series, like talk. So something that I can like take to something else. Maybe we'll just create a tutorial series out of it as well. Um, Anyways, I'm trying to use this sort of like planning system where I like create the, I don't know, chapters, themes, um, and then we sort of like go from there. And this could like maybe help uh organize like when I have when done is, and like what expectations are for the project. It's gonna be an experiment. We're gonna see about it. So what I've done previously, and it started yesterday at the end of the stream, I created like just basically an outline of like the sections, and then I went through and I added a bunch of just sort of like notes to things. This is Notion. I was experimenting with like using these like drop down notes in case I wanted to like actually just make this a giant article, but I realized there's probably just like I don't know if I wanted to make it like a giant article or if each of these would be like its own video or like potentially a series of videos. I'm not sure yet. It's brand new to me. So we'll figure it out together. I'm still like getting used to like how to organize things in Notion. I'm not completely sure I like the this thing where I can like hide stuff in. It might be good at maybe we'll see. Okay, so the big let's just go through and see what things we can actually create little videos and experiences for. So I plan on starting this with like introduction to like ECS. I went through and I actually did some research this time as opposed to the last time where I just looked at code from other ECS systems. So Wikipedia has a really interesting definition of ECSs that I don't know if I had fully that copy link just copies. Oh my gosh. Okay. There we go. I take it there's no dark mode for Wikipedia. At least I don't have like a dark mode extension for Wikipedia, which is unfortunate. I'll make this side here. So when I was reading through this last night, I was actually really interested to learn that it's only 2007 was when like ECS started, I'm so used to a lot of architectures starting like, in the 80s and the 60s, and then like disappearing for a while and then coming back. So it is super interesting. Also, I didn't know that Apple's gameplay kit used ECS. Although I suppose that it makes sense. So the definitions here they use. So like an entity is just an object with a unique ID. I previously have been using the idea of like an entities just being a column in the database. And actually they mention here that essentially an ECS is an in-memory. ECS resembles the design of databases and can be referred to as an in-memory database. That's actually really like good in my mind for like what how to like think about it. So like we're essentially creating our own database. And it's a very simple database, and only we're going to use it at one time. It doesn't have to be like a multi-purpose database, but it is interesting to sort of think about it as an in-memory database. So one thought here, entities. What does this really mean to us? Here it's like an entity is a game object with just like a plain integer as its ID, which I want to open up VS Code here. I also want to check to see whether or not if I add a new folder to a workspace, I want to go find BBECS. Where did I put that? Oh, is that in a Rust workspace? I bet that's in a Rust workspace. It is. Previously, when I tried this, Rust Analyzer was not very happy. It's not super unhappy. All right, so what I want to do, I'm gonna create a new branch for BBECS. Do I still have that open here? I do not. Let's go ahead and just do that in here. Do I have Git? I do. Check out. Let's create a new branch and we'll call it there's like level up skills. There. Okay, so I'm new branch. So anything I make changes to, if I make any changes and I keep them, I will not accidentally destroy anything. Also, like I plan on keeping this branch around, the main branch around for historical purposes, but I may actually just like rewrite everything. I was thinking through how I use ECS, and I'm not so sure. Like, I don't think I would necessarily want to create a tutorial building the way that we built it, because we built it using enums, so that the way there's no dynamic dispatch, which is faster, but it uses potentially a huge amount of memory, and it's extremely specific for like my programming. Like I don't think anybody else can really use that. There's a different way of doing it, which is dynamic dispatch, but that's neither here nor there. What I want to do right this second is sort of like think about this Wikipedia definition of ECS and see, does this make sense? So we'll just start with wikipedia, ECS. I mean that. Oh no. Okay, so their definition is an entity is just a general purpose object. So in Rust, a general purpose object would be a struct, right? So if I do something like I am in a branch, so I might be able to get away with just removing everything. Switch to new branch. I am definitely in a new branch. I don't have VS Code set up to like hook up to branches because I was running into weird trouble with WSL and non-WSL and get Kraken and everything together. So it's either command line or get Kraken. So if I just do this, if I just start over with this, let's say. Let's just delete all you. We'll delete all your tests too. We'll just start a new file, live.rs. So if we have entity here, so we have like a struct entity. And if we just say like you have an ID, and we would probably say that you're a usize, so that way you are the column in the database, right? Because the database is going to look like we're going to say entity is a series of it's the components. So components would essentially be a row. So entity is a essentially column of components, which is the data row. So that's a column in the ECS, which can be seen as a in-memory database. I should be able to multi-align this, right? Or I could just do that. Instead of thinking of it as rows and columns inside of Vec, you could use a hash map instead. Well, yeah, actually, I think like this is where it can get interesting, because like, if we think about it in that way, could we use a hash map? Like, and like, what's the purpose of like, what's the real purpose of ECSs? Now, I know like one of the original purposes is memory management. And like minimizing cache misses. But is that the only purpose of them? I don't know. It's a good question. I don't want to do that. I want to do word wrap. There you go. If I can retoggle this. Okay, so if entity just has this one ID and that's that thing. Now I'm using the usize here because I don't know what anything else is. Also, I don't think I've said hello, so good morning, stacking. Hello. Components. The raw data for one aspect of the object is how it interacts with the world. Labels the entity as possessing this particular aspect. Implementations typically use structs, classes, or associative arrays. Okay, so we don't have just like components, right? Like we generally wouldn't have something like struct components like that. Ravi 387, Nightbot got you. What are you trying to say? Share. It's a GitHub project, digit recognition web app. What's that about? Those ones, like, it's, let's see, digit recognition web app. I don't have like, I'm streaming on this computer, so I can't like load that up in a in something else right now. This is a digit recognizer app. That's really cool. Perhaps you could share that on the Discord. And then we can go check it out later. Are you just trying to share it off? So this is like not how we can create components like this. This is not what this means. We would have like singular as components, and it wouldn't be like named component in this case. We would name it something like location, right? And so it could be a struct. So have like X F32, Y F32. It could be something like this. So example of a struct based component. Each entity should have one at most of each of the components. But there's other, like, we can use other types of components too. So here it could just be structs classes. Well, in Rust, struct and a class are the same thing. Or associative arrays. So that could be, let's see. So another one, you'd word that way better. Example of a struct-based component. Each entity could have a, see, each entity can have many components, but should only be one of each component type. I'm talking about, classes and structs are the same thing. Yeah, that's true. So classes, when you're first starting out in Rust, classes and structs look exactly the same thing. Ravi, can you design front end in Rust? Yes, but it's not as easy right now. You can absolutely do WASM, but there's only like a couple of front-end frameworks that I know of. So there's U, and then there's also, what's that other one we looked at? I forgot what it's called. That's also a WASM. Seed. There's U and Seed, which I've heard of. There's this website that you can go to, which I don't have on this browser. I have over here on this browser. I should move you in here. So there's this website that Mozilla hosts on their wiki called Are We Yet, which is really just a series of collections for Rust, like that can it do something yet. So what we want is Are We Web Yet? Right here. And then we're gonna go to in detail web frameworks, I think. So there's server web frameworks. Okay, so here's the front end web frameworks, and here's all the choices that you have. So the ones I am aware of and that I want to check out, I've heard a lot about iced. I've heard really good things about it. I've not tried it. I have heard and tried seed, and you ran into a little bug, but I think it was my fault. So I'm not judging them. I want to return to it and try it again. And seed looked really cool. I keep on seeing about iced in the subreddit. I just see like posts about it being updated and people using it. Seems pretty cool. So I would check out any of these if you want to do front end Rust. I think my next one is probably going to be you to try this one out. Okay, but back to this. Classes are different. Like you can't use like the new keyword in Rust. There's no like object spin-offs, although you can create structs from them. So there are like blueprints exactly like classes, but there's no inheritance like most languages idea of a class. I'd say it's closer to maybe an object-oriented language's version of a struct, right? Because C# has the idea of a class and a struct. In fact, can we go take a look at that? Can I search for C# like that? C# struct. Yeah, you could create a struct in C#. So I think that the structs in Rust are a little bit closer to the structs in like here. Higure, good morning. C# difference between struct and class is mostly that struct is value type and class is a reference type. Oh, really? Okay, so I did not know that at all. Shows like my lack of C# knowledge. So would it then be accurate to say that the struct in that is any language that have classes? Oh, okay. Yeah, like well, so I've used Python and JavaScript classes, but they don't have structs. So those two probably are not counted here. Like we're talking about things like C++. So these are like type creations, not reference types, but a value type over here too. So am I correct by saying that these are similar to the structs in other languages? They should be reference based in Python, but you're not sure. Yeah, I don't know either. It's been too long since I used Python, and it's probably changed too much since I learned 2 and not 3, and I heard that 3 changed everything. Okay, so then we have struct, maybe like, yeah, size is good. So size, but then this is just going to be something like a F32. So this is still a struct-based component, but it's just a single, I guess I could still struct. The reason why we might want to use structs is due to, I guess like we do that, and then arrays. Yeah, I don't know if that makes sense. Is class automatically make ref and allocate memory on heap? Class in C++ also allocate and stack by default. Okay, that's good to know. Hello. You want to come up and say hi? You done? I think he's hunting for spiders and bugs. Okay, so like these are the different things. Now we can't have like an array. It's like according to Wikipedia, essentially my choice is here, like let it wouldn't be a location. What's something? Oh, here, we'll do velocity. Velocity equals something like F32 2. Oh, hold on. Can I just do this? Yeah, that. I kind of need to be inside of a function, don't I? So this would satisfy. What does it mean by associative? So this would satisfy the array, but we're going to run into type problems. String in Rust allocated memory in a heap. String is okay. So this is super easy to like complicate here. String is on the heap. Stir is on the stack. So it notice like this is an abbreviation of string. So we generally call them stirs to like keep them separate in our mind. So this is like on the stack. This is on the heap, but behind the scenes, strings have stirs. Yeah, there's struct with a pointer to the memory, and then this struct ends up manipulating all of this stuff, like, you know, growing it, shrinking it as much as you want. So it's basically a struct just like this. And you can actually go look in the documentation at its implementation and see what it looks like. Whereas this is like the raw thing. This is the real thing. So I don't think that this makes any sense, because if I do have a like a vector of vectors, I would think that a vector would work here so I can grow and shrink it, but I could also like limit the number of entities that we have, which would make it be a not. Like if we're making a table, we have a choice of array, vectors, or something else, right? Okay, so system. Each system runs continuously as though each system had its own private thread. I think what's really important here is that it's as though. So to me, this is saying that you need to write the systems as independently running functions that don't care about each other and don't like need state outside of themselves. This is another way of saying it is that you just need functional functions. Because they have to be completely self-enclosed. If they're in, threads, they can't access anything else. This is especially true inside of Rust. So, A system here might be, let's say we have like two structs here. Let's say we have also a struct velocity, which is going to have an x and a y. And then we're going to have a system here. So a system that will take each location and velocity and update them based on the physics of the world. Sure, yeah, that sounds exactly right. So then it's just a normal function, right? So we might call this update locations. Yeah. Update location system. I usually like adding system into it. It takes entities, but really we like at the most basic, if it just takes these two things, like we might take like the world and it's going to query this world. So yeah, it takes, you know, however it works, it needs to query for these things. So takes the world. So get the locations and velocities from the world. Okay. And then can I give some ways to earn money as a programmer? I mean, like the potentially easiest way to earn money as a programmer is to get. Let me rephrase that. It's not going to be easiest. The safest, most secure, long-term way of like getting steady income from a programmer is to get a standard job, like a full-time job with another company, and they pay you a salary, and you give them like 40 hours a week, and then you just do whatever they want you to. So that would be a way to earn money as a programmer. That's like the standard normal way. Freelancing, making your own products and selling them, but those require business sense, and you have to learn how to be a business person. Those may or may not be as easy to do. In fact, they're definitely much harder. Okay, so get the locations. So here we somehow need to like query for the all the entities in the world. Specifically, we want to like do something like let maybe the locations get entities with components like, you know, location, velocity. I am in a full-time job, yes. And then we'll be able to like loop through each of these, and we're good to go, right? Because these would be a vector of these, and then we just simply update it. These don't exist, so errors. So what's the point of an ECS? Initially, my only thought was to minimize cache misses for minimize cache misses when loading, and cache misses are. Let's see, how would I have like a visualization for that? Let's say we have. Am I in a full-time job? I am. I am in a full-time job. I do not use Rust in my full-time job. I use PHP, JavaScript, pretty much those two. I mean HTML, CSS, but those come with JavaScript usually. Okay, so what is a cache miss? maybe back to here. So like one of the, oh, I actually wrote it down already. Minimizing cache miss is a huge reason why we might use an ECS. What does that mean? That means every time that the CPU requests data from the from memory, it gets a chunk. I think it's chunked to the left and the right. So to the left and right of the like the exact memory location. It then stores this in cache, cache to use it later. So if I request like position 1, and it loads up. I wonder if I can do something like this. We have a array here of like 1, 2, 3, 4, 5. So if I do something like let values equals, we'll say this is Rust. If I want 3, it'll like, if even if we have like a very small cache, it'll grab all of this, like everything to the left and to the right. Maybe I'm gonna get to that. It's taking me a while, but I'm gonna get to that stacking. So it would grab all of this stuff, right? It would grab 1 through 5 and store that in cache. And then the cache is usually big enough that if I have like other values equals like, I don't know, 10, 11, 12, 13, 14, 15. Let's say we have like these other ones. And so I want, give me value at this position and give me other values at this position. It will load up like, 2, 3, 4 and like 12, 13, 14, for example. It will load up both of those into cache. And therefore, if I'm actually updating each other, like saying, okay, 13 plus 3, add them together, mutate this array, go on from there, that's all in like the cache, which if you want to think about it in terms of architecture, and let's actually create a freehand for this, because this is going to be, maybe we want to do that. This is going to be, I'll just call this ECS. I requested dark mode for this. They responded to me saying like it's been added to their request and it's like being considered by the freehand team right now. I am hoping that they do implement that. That will be amazing. Okay, so how do I want to do this? Let's say, okay, we have a CPU. And we often see memory as being something like this. So your memory, actually, memory is often got like lines like this. And so seen as sort of like a table of like rows in a database of items. Arrays in memory are stored next to each other. So if we have like our example of, we have something like let values equals 1, 2, 3, 4, 5. This is going to be down here. 1, 2, 3, 4, 5. They're all right next to each other in memory. So when the CPU says, okay, I want to load, so instruction, load, whatever the memory register for this is. So memory address, so 0, 1, 2. Load memory address 2. Now, in reality, these memory addresses are pretty crazy looking. They're not as simple as like a UI, a U size. They're actually like, these crazy long registers. And array lookup is technically the original position and then take the index you want and then add that by bytes. That's true. That is actually true. So load memory address 0, like offset 2, something like that. So like offset 2 of that. Then what's going to happen is it's going to load up this position in memory, but because CPU manufacturers understand that if we're going to mutate and like we need this 3 here, we're probably going to need this one and this one. So let's say we have a really, really, really small cache. This is our cache. This is our memory. Then it's going to load up 3. But it's also going to load up this 2. And it's going to load up this 4. And if I also at the same time have like another one of these, but instead of like, we'll increase these to 10, 20, 30, 40, and 50. So maybe something down here. We also have a 10, 20, 30, 40, and 50. If we also search for 30 here, it can grab this up. So it can grab these things too. So it's not just only going to grab one array, because that would be useless in ECSs, right? The caches can handle multiple locations in memory at the same time. So it's like, give me this thing, oh, give me this thing, give me this thing. Okay, I'll just grab all those things and store them into the cache here. In modern days, are you guaranteed that the cache is CPU cache? I can't imagine not. I would imagine so. I think so, yeah. What computers don't have a cache and a CPU anymore? Like the modern Intels, the modern like Threadrippers, like AMDs, and even like Apple. So Apple, for example, has really good caches. And this is actually like a trick. If you want to be cheap on your hardware for a computer, for like a gaming computer, don't cheap out on the cache. Like look at the CPU. If the CPU is not as good as some other CPU, but one CPU has a bigger cache than the other, take the one with the bigger cache, because you don't like that can actually speed up things a lot faster than a better CPU. That can speed up things even better than a better memory. It's pretty crazy how cache misses in gaming can really slow you down. So this idea of a cache miss here is I want 3 and 30. Great, I do that, I add 3 and 30 and I mutate this and I make this be 33, let's say. Perfect. And then I say, now give me 5 and 50. Which I don't have that here. That's a cache miss. I didn't use 4 and 40. I didn't use 2 and 20. So now it has to unload that and reload this from memory in. And I remember when I first started like doing any kind of like work with computers, memory was like the fast thing. I remember like in-memory databases, like, don't go to disk is slow. Now memory is slow. Don't go to memory unless you absolutely have to. So memory has not kept up speed-wise with CPUs. It's actually like it's fast for compared to us humans, but it's slow compared to the CPU. Big grain of salt with that though, since the manufacturers, retailers list CPU cache sizes however they please. Oh, is that true? Oh, that's too bad. Also, good morning, Hickory. Some just add up all cache Oh, they just add them all up. Oh, that's too bad. Because like I know you can have like the L2 cache and you can have the L3 cache. Memory is still thousands of times faster than the fastest SSD though. That's true. That is absolutely true. Memory is faster than whatever long-term storage that is. It was 10,000 times 15 years ago. Yeah, I haven't looked it up recently. I would not be surprised if you're right, Unix Zealot, that it's only like 100 times or maybe even only 10 times or so. If you think about it, SSDs are kind of like memory, right? Except just in like much bigger and slightly different form factor. But like they're not spinning disks anymore. That's usually what you waited on previously, was literally a spinning disk to find your data and to go and get it. You still have IOPS issues with SSD? I mean, yes. Yes, that's true. And SSDs have like other potential issues too. Like they have to like not, they have read-write issues with like the same blocks over again, which I don't know if ever been solved. But doesn't really matter if you don't use it. If you treat that as secondary memory, which this always stuck with me ever since like I took a few courses in computer science before I went out of that way and went into the computer information technology route. But I do remember the different, like there was a big talk about primary memory and secondary memory. So like memory is the primary memory here. This is like RAM. And secondary memory is like the disk drive or the SSD. It's the thing that you like store your stuff on when you're not using it. That's like a thing that you can like think about, is like just treat it as like long-term storage. And when we're writing programming, we generally want to think of in terms of how to use just memory. If we have to go to disk, that's really slow, and we just have to understand that. But anyways, this would be a cache miss. If I want 3 and 30 and then I want 5 and 50, it has to unload all of this, so it just get thrown out, go and request this off again. It's slow for what the CPU can do, and the CPU is just sitting there going like, oh, okay, fine, I will wait. The kernel will usually then go and do something else while it's waiting for your code like to load all this stuff in. Your code, however, meanwhile, is slept and is literally doing nothing. If you're breaking a game in which you have to be extremely fast, this can be a major problem. So if like the first big thing about why we might be using an ECS. So why use an ECS? Actually, I have that over here, don't I? Why use an ECS is minimizing cache misses. However, when reading through this document here, I noticed this. Common ECS approaches are highly compatible and are often combined with data-oriented design techniques. So although an entity is associated with its components, those components are typically not necessarily stored in proximity to each other and physically mirror. Okay, so anyways, this one sentence right here caused me to think that there might be another use case for ECS that's not really the game design. It's not really about optimizing for speed and memory usage, but optimizing for functional programming usage. And where we don't necessarily care about cache misses, that's just going to be a nice benefit we potentially could get if we wanted to. But instead, we can optimize for the systems, for like functional programming to access and then manipulate this data. Key features of functional programming include the having state all in one place. So if our state is in this world, in this in-memory database, and then we just have a bunch of functions that can go back and forth to manipulate, retrieve, and read, and whatever this data, then we can basically, this is where stacking, we could potentially look at other data structures. Like, what if we used a Hashmap to store this? It would be slower because we'll have more cache misses, but what if we don't care about that? So anyways, that's something that I'm like really interested in. Like, would it make sense? Like, would it make sense to build a non-game using an ECS? Like the idea of an ECS. You say binary tree and call it a day. We're getting, let's see, binary tree. Would that work? I don't. Maybe. Probably not. Like behind the scenes, a lot of things use binary trees. And don't a lot of databases use binary trees behind the scenes too? Or am I thinking about a different tree? I don't actually know how like Postgres or MySQL or even like databases like Mongo store their data behind the scenes. I've never looked into that. So we can say that I've created a database, but a very simple, database, ECS database essentially. So anyways, if I wanted, we could still have these structs as like, these component structs would still be the case here. But how we store them, as long as it appears to us in something that's easy to get. So maybe we don't do that. Probably want something like this, right? You are a series of columns. Each column is a thing, right? And then we're gonna have a series of rows, and each row is a thing. And this gives us a database. It should remind us of something like Excel or Google Sheets, depending upon where you lie. And that's exactly right. That's what we're building here. So this would be something like location, this, size, health, maybe even like the mesh, something like that. And you can have as many of these out, and then we'll have like the actual data going down here. So the types can be independent of each column, but have to be the same across a row. So this might be something like X is like 4, Y is 5. And then this would be the same all the way down. Just imagine the numbers are different. Size might be something like 15, health might be 99, and mesh might be gobbledygook of the mesh, whatever struct that looks like. So if we do it something like this, Lumicode, hello. If we want it in our headspace to look something like this, normally we would say just like a vector of vectors, an array of arrays. But would a hash map work here? A hash map might be something where we have an ID, so an entity with this ID here. We would have like ID of 1. And then you would have like just pointing to, would we point to where this is then? Everything is a 2D array if you try hard enough. I guess that is true, right? Like if we go deep enough into it and we get there. You hated 2D arrays with a passion in your college course days. Welcome back. So could we design an ECS to not optimize for cache misses, but optimize for just independent little pieces of data? So in that case, we can have like the hash map of like locations. I don't know if I could do that. I'm having trouble like thinking about how that lays out here. Because like this would be like their key, right? The key, and then the value would be, it can't be the rows. It could be something like we're gonna have this anyways, and then we'll just have like something else like this entity grabs all these other things. I don't know. I don't know how to optimize for. I don't know any other optimization. I think you just end up getting this regardless. Anyways, this is the benefit. This is what we're going for with an ECS. Essentially creating an in-memory database. Okay, so I think this is good. I can like off stream like actually write up like a full thing. Eventually we can do like a full video on like introduction to ECS. I'll I'll have to like probably think through it a little bit more, and then I'll do like an actual real introduction, like what is an ECS. This could be essentially a talk all on its own. Maybe like a lightning talk, or like a 10-minute, 5-minute talk. That could be interesting. Okay, so why build your own ECS when you can use an existing library? There are tons of these libraries. If we go look at the Are we a yet? Are we a game yet? Is there something on ECS libraries? ECS. So there's a bunch of these here. They're like Bevy ECS, X, Legion, and Specs are the ones I've heard of. I've used Specs and I've used Hex. And heck, Bevy ECS was forked from Hex. So there's that too. Although I think it's decently different now. But yeah, look how much there are. Like there's 10 of these. My favorite is still Specs. I still like Specs a lot. But why build our own? Let's see. I'm putting in here that so I remember this from MPJ's what was his show called? Like the Monday, his Monday show. But one of his episodes, which I can't remember which one anymore, he basically mentioned why, you know, you use other people's tools not because you can't build it, not to avoid, you know, the ability to do it. You use it because like you want to build other stuff, you want to take the time to do it. So you don't create your own editor because you can't build an editor. You use an editor because somebody else who's passionate about building an editor is spending the time to build it right. And we just don't have the patience or the inclination to build it right, even though the basic technologies that build it, we can do. So if we use something like an ECS, like we're going to build our own, it's really to like learn the understanding behind the scenes of how it works, but probably not to like fully use it ourselves unless one doesn't match our needs, in which case you have to do that. Then you have no choice. So to me, this is going to be like, this is learning, right? The reason why you build your own ECS for the most part is a learning project. So what do I want to do to get there? I was thinking about like different projects we can do for like to show off the ECS. We already built a flocking simulator with the other ECS. We built the asteroids game, which like both those are really cool. The asteroids actually showed a pretty big limitation, and I want to design something that we're going to hit that limitation again, so that way we can then also fix that. And I'm thinking of just a simple simulator that's similar to the asteroids game. Oh, sorry, similar to flocking, but has deletions, and that's going to be a zombie apocalypse simulator. So what do I mean by that? I mean, we have, let's say, these red, sickly looking zombies. And then we will, so let's say we have like a bunch of these around in the world. And then we have healthy, let's see, I think light blue will not trip up people with color vision. No, color blindness. I need to look up what the color blindness colors are. So The reason why it's zombies is because then I can just say like, hey, are you just always going towards like the nearest non-zombie thing, and you avoid each other. So we get like a little bit of a little tiny bit of what is it called, blocking simulation, so your avoidance with each other, and your attraction to the other. And then if you touch the human immediately dies and becomes a zombie. So we delete the human and we create a zombie at that location. I know I could just convert it over with a type, but I want to actually do deletions in there. So we're going to sort of like force that in. Probably what we're going to do is we're going to say like, you always die. And then you have a chance of like coming back. Maybe you got like 100% even. There's nothing to come back. And then that way we start with like all humans, maybe like 10,000 humans and like one zombie, and we see how long it takes for the zombies to win and kill everything. And humans can't fight back because this is a cruel and punishing world, and everyone dies horribly. So I'm thinking this would be a great project to show off this. And I want to check out the latest update in GGEZ, because if you haven't heard, IceFoxen found some contributors for GGEZ, and they have taken over the project. So it has switched. If we go take a look at it in GitHub, it is where it is back to being actively maintained. It is no longer in maintenance mode, which is really awesome. And they brought us to, we now have 060 RC2. So we have another release candidate version. So I kind of want to check this out to see what it's going to look like. So let's go ahead and save these. Let's open up cargo.toml. I want to do GGEZ 0.60 RC2. I think this is going to work anyways, even though my cargo toml extension just hates this with a passion because it wants me to not use any of these release candidates. But I want to see if this works. I guess also for this, let's maybe not do this one here. Let's spin up a new project, because this is a library project. Where do I want to go for this? Let's go find someplace. CD, let's, I'm probably not going to put this on GitHub. I just want to see if it runs. You think RC2 are stashed under pre-release section in cargo and was added not too long ago. Oh, okay. That makes sense. That plugin hasn't been updated, but I can also see it like maybe it should yell bloody murder if you're not using like a release version of it. Okay, so I want to go into playgrounds. CD, documents, code, playgrounds. And let's go into, let's also Rust up, update, make sure we're using the latest version of Rust. Okay, so it looks like we're getting Rust 1.53.0. Hi. Hi. Okay, or not. Looks like they didn't add it to crates.io. Oh, really? No? Okay, just want to wander around. Step on stuff. Great, where's the documentation? Oh, it's here. Oh no, look here. Versions 060RC2 right here. So it is here. Okay. So let's do a cargo new this is GGEZ RC2. I'm gonna name it differently in case like it's weird. Okay, so we're creating a binary package for that. Let's add it to this workspace here. So this is code, playgrounds, you. Okay, so our big thing is, no, not that. I want GGEZ. Specifically, I want that. Okay. You're gonna yell at me, no doubt. It's gonna be fine. Now documentation, let's see. How do you say that we should get going? So make a context, okay. So standard context using context builder, new. So if I just take this, will this run? Hey, it's downloading all the things, so it can find it. It's definitely deployed to crates. So I think what it is crates hides it. I think crates hides the pre-releases, the release candidates, but they host them. They host the data for it. Which is actually pretty cool. I like that. Look at this. This is a faster compile time now. But okay, so expected one type argument for what? You need a type argument now? Wait, really? Missing generics for trait event handler. Trait defined here with one type parameter E. E for my game. Oh, that's interesting. So looking at this, it doesn't... Hit the pre-release section again. You need to click the number of versions and you can find it there. Yeah, that's where I found it in here. I went to up here and then versions. Now, what's interesting is that this doesn't work This example doesn't work. How about their website? Oh, look at that. They have a different example here now. Let's try this. There we go. Okay. So this is working on Windows. Nice. So we could try this. We could try creating it in release candidate 2. I'm really interested in see like what the new things are that they're doing, because I've heard that there's some really cool fixes in this version. But a lot of the architecture is changing as well. So what's the big difference here? We import event handler, and then we have to give it, we have to tell it like the game error. Game error, that's fascinating. Okay. That's the type for my game, and then, okay. I wonder if that's, so now we can return our own errors if we wanted to. That could be fascinating. So if you haven't ever seen GG Easy, if I wanted to like draw a circle, let's say, we have to create a mesh first. So let's create like a mesh equals, I think it's going to be a mesh builder. Can't find that. Hold on. Graphics. Maybe not. Where we were. Okay, there's still a mesh builder. So it's still all that stuff. Builder new. Then we'll do something like circle. You know, Copilot is just screwing this up. This is not helpful. Because I want to do, okay, we create the new one, and then we could do circle, and then it's the mode, points, radius, tolerance, all that fun stuff. Okay, so that circle. Yeah, so this isn't telling me what this is. Which either means Rust Analyzer isn't working, or Copilot is screwing it up. It's so long to restart. Okay, Rust Analyzer restarted. Or not. I think, okay. There we go. Okay, so now if I do circle, okay, now we can do draw mode. So we want a draw mode, like fill, let's say. Then we want a point. We can do a point of like, let's say 50.0, 50.0. Then a radius, let's do like 50.0. A tolerance, 0.1, and then a color. Let's do black. You now return a result, so we have to question mark you. Okay. So that gives us this mesh builder, and then we can build you. Hand the context, question mark you. We need to pull in. Nope, not that. You don't know how to pull in. Oh, is there no more? Okay. Graphics color black. Okay, so pub const. So graphics color. Oh, look at that. There's like black, red, blue. That's nice. Okay, so that gives us a mesh. And then if I want to draw this out, we're going to do a graphics draw context mesh. That's close. So graphics draw. We do CTX. The drawable, so it's a reference to the mesh. And then params. So it can be draw params. Yeah, let's just do default. Then we'll question mark you. And so if I run you, there's the circle that we created. So this is like the basic of like how to get something going in GGeasy. This looks like it could work for us. It's a little bit weird. But there's some nice things in here that can like improve our performance in GGeasy. I could also just use 0.5 while waiting for 0.6, and maybe it'll come out, you know, sooner, maybe, possibly. So anyways, this is an option. So technology, let's see, I'm thinking about 0.6, RC2. Now air, I really like the air crate. They have a 4-month gap between RC. Yeah, well, they also changed contributors in that gap too. So it's hard to tell what the that's another reason to like go for that, because I don't know if I want to. I don't know if I want to wait. If it works for like the basic things that we're doing, I think we'll be fine. My plan is like to build out the ECS that we're going to do a tutorial on, and then build a tutorial for that. That's the plan. Is basically it's like a rebuild of our ECS once again, but like in a better way. So, all right. Okay, so air crate. I'm planning just using air probably for our errors, and then we'll use game errors for like everything else, which I mean is just pretty standard. I'm actually really fascinated with this impl game error. Like, could I potentially throw in error? And just put in like result here. Okay, I need to tell Copilot to stop doing that. Could I do result Oh. No, I can't. The trait bound result game error. Standard errors are not satisfied. Errors not implemented for. Oh, because it's the error type, not result. Okay, hold on. Can I do? Is there like an error? Error report. No. I know they do somewhere. But I don't know. Handler. Oh, they might be using error. Yeah, I changed you. The T is just a basic error trait. Okay, that makes sense. That's sort of like what we're seeing it's trying to do. But this is. Then if I try to return you as just like a result, an error result, like that. But whatever this is, I'd have to go look up error. I don't know if it matters too much, but that would be really cool if I could just like replace my own errors with theirs. And I could like create my own error then. So that I could actually see a reason for that. Now, I don't know why they wouldn't just do like a result type that has both like the success and the errors. So for the error type, simply choose game error or something more generic if your situation requires it. So I guess if I created like a struct error and it implements error, then I could just throw this in here. So that could be really cool. I'm not going to do that right this second. That's good to know. Okay. Back to here. So can we replace all? I know error must not be. I think that it should, although it's using anyhow behind the scenes. So maybe we need to use anyhow as error. Possibly. I know that anyhow should. Can replace all errors with our own error crate. Let's see. I want to do like something on why OOP style won't work for this. It's the deletions of like the multiple vectors, and then we can get into like planning, like building a thing. So my idea here is to do a naive pass at it, and then we're gonna benchmark it, and then improve it with like a less naive approach. And then the big thing here is that I want to use bit masking, which will help us essentially not have to have deletes for this database. will reuse spots, which is really cool. And speeds everything up by a tremendous amount. But okay, today was a lot of planning. Not even planning, it was like introduction before we even do the planning. What I'm thinking of tomorrow starting off on was we have to determine how we want to like build our ECS. I'm thinking we have to take our project and like plan that out. So I think tomorrow morning, that's what we're gonna start with, is planning the simulation. And then because of that, we can choose what are the components, how are they gonna communicate with each other. We can figure out the architecture of like the app outside of the world. And then because of that, we can figure out what our ECS at a bare minimum needs to support for that architecture. So I know today hopefully wasn't too boring. Tomorrow might be still a little bit boring, but we'll be getting there shortly. So with that, there's a bunch of us. Let's go ahead and do a raid.